All right, finding a polynomial given the roots. The most common polynomials that we should be familiar with are quadratics. So if I had x squared minus 6x plus 9, and I was asked to factor this, we would get x, and x is x squared, and then 3 times 3 is 9, and we both need these to be negative so that we get a negative 6 when we FOIL it out. And so our roots from this are x equals 3 and x equals 3, because a 3 in both of those sets of parentheses makes a 0. And so what we're wanting to do is go backwards now. So given the roots, we want to find the factors, and the factors will allow us to find our quadratic. And so in this example here, we can say that x minus 4, because 4 minus 4 is 0, and x plus 6, because 6 minus, or negative 6 plus 6 is also 0. And then we can multiply this out. X times x is x squared. X times 6 is 6x. Negative 4 times x is negative 4x. And negative 4 times 6 is negative 24. So our polynomial that has roots of 4 and negative 6 is x squared plus 2x minus 24. And we should be able to go back and factor that and get the same answers. So if we take x squared plus 2x minus 24, x times x is x squared, and then our multiples of 24 that has a difference of 2 is 6 and 4. We would need a positive 6 and a negative 4. And so as you can see, our solutions to this when this is set equal to 0 is when x is 4 and when x is negative 6. Now, very similar example, a little more involved, is when you have a fraction as your root. And so let's look at this. I think it's clear that we would use x minus 4 as our first root. And most people would probably say x plus 3/4. But I want to challenge you to think, when you look back at this previous example, would you have come up with negative 4 times 3/4 to get your constant value at the end of the polynomial or the quadratic? Probably not. So if you take this 4 and move it in front of the x, we get x minus 4 equals 4x plus 3. The root is still negative 3/4, because if we take 4x plus 3 equals 0 and solve this, we're going to get 4x equals negative 3, and we divide by 4, we still get x equals negative 3/4. And so that's what we want to use. So if we take this over here, we have x minus 4 times 4x, clean that up, plus 3. And again, we use this FOIL process. So we're going to take x times 4x. That gives us 4x squared. And then x times 3 is a positive 3x. And then we'll take negative 4 times 4x, and we get negative 16x. And then negative 4 times 3 is negative 12. And so what we end up with is 4x squared minus 13x minus 12. And so this is our quadratic that has these two as roots. All right, so those were kind of warm-ups. Now we're going to deal with some complex numbers. And so if you look here, similar idea. If you notice, when the root was positive, I wrote x minus the root, and when x was root, the root was negative, I wrote x plus the root. And so you can do the same thing here. We're going to have x minus 2 plus I. I've just changed the sign of the two numbers. And then here, we would have x minus 2 again, but because the I is positive, we would have minus I. Now, we have two trinomials here, and when you multiply two trinomials, you should get 9 terms. There's a lot of work that goes into this, and I can show this to you. X times x is x squared. X times negative 2 is negative 2x. X times negative I is negative xi. When we take negative 2 times x, we get negative 2x. Negative 2 times negative 2 is a positive 4. And negative 2 times I is a negative 2i. And then when we take I times x, we get a positive ix or xi. It doesn't matter. And then I times negative 2 is a negative 2i. And I times negative I is a negative I squared. And back here on this I, this should have been a positive 2i because it was a negative 2 and a negative I, which would have been a positive 2i. So just pay attention to what you're doing. Make sure you're not making any mistakes. Now we want to combine like terms, and I do have 9 terms here if you want to count them. There is only one x squared term, so we get x squared. And then there are 2 negative 2x terms, which gives us negative 4x. The negative xi and positive xi cancel. There's only one constant term, so plus 4. Your plus 2i and minus 2i cancel, and then you're left with negative I squared. And so if we recall I squared equals negative 1, we can say x squared minus 4x plus 4 minus a negative 1, which gives us x squared minus 4x. And minus a negative 1 becomes plus 1, and so we will get plus 5. And so this is our quadratic that has roots of 2 minus I and 2 plus I. Now, to challenge you here, if you look at the pieces that we kept this, 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 and this. These 4 pieces come from x minus 2 times x minus 2. And then the other piece that we kept was our negative I squared, which came from positive I times negative I. And so a shortcut to doing these problems, and it only works in this setup, is that you could have multiplied the green parts that are highlighted together. So x squared, if you just do the FOIL there, x squared minus 2x plus 4, and then I times negative I is your negative I squared. And so that gives us our x squared minus 4x plus 4 minus a negative 1, which again is x squared minus 4x plus 5. All right, so you got the long way or you got the shortcut way. Either way, it doesn't matter as long as we're getting the correct answer. In our next example here, these are imaginary numbers. In this previous problem, they were complex because we have a real number in the 2, and then we have an imaginary number in our i's. And so we have a complex number, or a imaginary and a real, which is a complex. So here we just have 2 imaginary numbers. It's going to be a much simpler example. And so again, x, we change the sign of our number. So it was a negative 5i, so I'm going to write plus 5i. And the positive 5i becomes x minus 5i. And we just do a traditional FOIL here. X times x is x squared. X times negative 5i is a negative x, let's just say 5ix. Make it simple. And then you have 5i times x, we get a positive 5ix. And then you have 5i times negative 5i, which is a negative 25i squared. And so our middle terms are the same, except one's positive, one negative, they'll cancel. And so we get x squared minus 25 I squared. And again, remember that I squared equals -1. And so we get x squared minus 25 times -1, which is going to give us x squared plus 25. And so there's our polynomial with -5i and 5i as roots. And for our last example, we're given 3 roots. So this will be a cubic. I would suggest first, well, let's first write our factors out. And so 2 becomes x minus 2. -3i plus 2i becomes x plus 3i plus 2i. So we change the sign of the 3 to positive and the -2i to positive. In our next set of parentheses, we'll again change the sign of the 3 to positive, so plus 3. And then we change the 2i to negative, so minus 2i. And again, I would suggest using the shortcut. I would do the second set of parentheses first. It doesn't matter, but I think that it's going to make the process much simpler. Plus, we can use the shortcut. And so the things I have highlighted are what we multiply according to their color. And so we're just going to drop this x minus 2 down for the next step. And then we're going to get x squared plus 3x plus 3x plus 9, and then 2i times -2i is a -4i squared. And let's simplify this set of parentheses on the right before we go any further. And so that's going to give us x squared plus 6x plus 9 minus 4 times I squared, which is -1. And so x minus 2 is x squared plus 6x plus 13. And you may not need to write as many steps out as I did, but I think it's helpful for you guys seeing in this video. And so our third thing is taking the binomial times the trinomial, which is going to give us 6 terms, bi being 2, tri being 3, and 2 times 3 is 6. So we're going to multiply the x times all the terms in the trinomial. And so we're going to get x cubed plus 6x squared plus 13x. And then we're going to multiply the -2 by all the terms in the trinomial. And so we're going to get -2x squared minus 12x, and then a -26 at the end. And so we want to simplify this. We want to put our terms in order of their degree. So we look at their largest exponents. So x cubed will go first. Write this in a different color. So x cubed goes first. There are 2 x squared terms. We have 6x and -2x squared. And so that's going to give us a positive 4x squared. And then we have a 13x and a -12x, which gives us a plus x. And then our constant is at the end, minus 26. So this is our cubic that had these as the 3 roots. And so 1 real, 2 imaginary. Just remember, imaginary roots always come in pairs. Thank you.